Let's talk about printing the tree. So here's what I want to do. I want to write the body of the print function so that when I say tree.print, like in the main out here, when I say tree.print, if the tree contains content like this, I want it to print all the elements out like that. Now you might say, well, why did they come out in that order? Well, okay, I guess I don't really care what order they come out in. Maybe we could think about that in a second. But just if you can just print them all, I'll be happy. If you're printing a linked list, how do you do it? You got to look at all the nodes and stuff, right? How do you print all the nodes of a linked list? What would you do? Not a tree, just a regular linked list. Yes, sir.
Use recursion.
You'd use recursion to print a linked list? Or are you answering how to print a binary tree? Or both?
Binary tree?
I'm not laughing at your answer. Your answer is fine. It's just, it reminds me, my fiance Mariana, she has kind of a California dialect. And the way I think of that is like she ends every sentence like it's a question, and she kind of goes up at the end of the sentence. And like you did that just perfectly. So in a really creepy way, you just reminded me of my fiance. Okay. All right, let's move on. So yeah, you said use recursion. I really like that. I mean, the question I was asking was slightly different, but you answered kind of, you're kind of getting where I want to get, which is, okay, if you were going to print a linked list, remember we make a current pointer at the front, and we loop until it's null, and we do current equals current dot next, right? Okay, so your suggestion is to use recursion, and I want to do that, but I'm going to time out for a second on that, because if you tried to do the linked list way here, let's think about where that would lead us. So like, if they said tree.print, and I press F2 to jump inside this method. So I'm in tree.print. Here I am. And the only variable I have is root. So I could do like I did with linked list. I could say tree node pointer current equals root. And then while current not equals null. This is me like basically writing linked list code, but in a tree instead. All right? I'm trying to do it the linked list-y way. So I sort of like println or cout current data. And in a linked list, it would be current equals current next, right? Okay, but this thing doesn't have a next. It has like a left and a right, right? So I could say current equals current left, or I could say current equals current right, but I can't go left and right, you know, and if I go left, I can't really get back here to go right later. Do you understand? Like, there's no really easy way for me to just walk around the whole tree and reach every node and print every node as I get there. A linked list is simple. It's linear. You just walk across. This thing is branched out and has this structure to it. So the gentleman's suggestion was actually a really good one, which is like maybe I could use recursion to help me print the tree. Now, binary trees are taught in these classes because they're basically a mashup of all of the topics that piss you off in this course together. A binary tree is basically pointers and recursion together. Boo. But that's why, you know, the teachers love it, because it lets me test you on both things at the same time. It's like, you know, the chocolate with the peanut butter mixed together, but evil, you know. I don't know, what's the like evil equivalent of the chocolate and the peanut butter? What's like two evil things joining forces? Who are the two bad guys or the two horrible ingredients? Suggested analogy, anybody? Who are two supervillains who team up? Ultron and Thanos or whatever? I don't know, I haven't seen that movie yet. I don't have a social life. Bush Cheney? No, never mind. I'm making too many political jokes. I apologize. Anyway, okay, whatever. Pointers and recursion makes trees. That's kind of the thought process here. So it's hard to print a tree using a loop. Instead, let's think of printing a tree as being a recursive task. Now, how is printing a tree recursive? How is it self-similar? If I'm asked to print this tree, how is that similar to printing some other tree? Can you describe the self-similarity to me, just English-wise? Yes?
subtree as your child nodes?
So I can print this thing, which is the root part, and then you said I have subtrees here and here, and I'm going to use like recursion for that. Yeah, so again, like always, recursion is all about having our code, our call, do a little bit of the work, and then magically having recursion do all of the rest of the work in a self-similar kind of way, right? And I think that's exactly what you're getting at, which is if I'm looking at a certain node, like the root or whatever place in the tree, it would be pretty easy for me, my code, to just print that node. That's not very hard. But then if there's a bunch of stuff underneath me, I could just recursively print all of that, and maybe that will work out if we got the code right. So maybe recursively printing a binary tree, maybe that is, let me, wait, how do I turn that off? Go away. OK. So if I want to use recursion, maybe I'll delete this code. That I don't want the while loop stuff anymore. So if I just printed or couted root.data, root data, endl, and then I want to use like recursion to print the left and recursion to print the right. But how do I tell it to print the right only or the left only or whatever? Like, if I'm going to call my own function, it seems like I don't know how to make it so that I can call my own function on part of the tree and not on all of the tree. Does that make sense? So that raises an interesting question. We've gotten into this situation before where we're trying to write a recursive function, and it doesn't have the right information that we want it to have, right? And how do we get out of that jam in general? You make a helper. And you could totally do that here. I mean, we've already learned how to do that. What would we do in the helper? What would the parameters be that we would want to be able to give it? Like what goes here where the question mark is? What would you do? Yeah.
So you need something like roots left to go in there. So I guess the helper method would be print and then fourth parameter would be like tree node something.
Ah, OK. So she said maybe the parameter should be like a tree node or a pointer to a tree node. And then here I could say root left. And here I could say root right, something like that. Yeah, that's a great idea. Let's write a printing method. But instead of just printing the whole tree, you pass me a pointer to the portion of the tree that you want me to print. And I'll print that portion of the tree. That's the idea. Now, in terms of writing the helper and declaring the helper, usually the way we do this is since we're in like a class, we want this printing helper probably to be a part of that class as well. So we go back to the binary tree.h. And here where we have print, we say, well, let's write a new one called like void print helper. And it takes a tree node for the node of the tree, the part of the tree that I'm going to print. OK? And if you want to get picky about it, this is probably an internal method that we're using to help us implement the real print function that the client is going to call. We probably don't really want the client to call print helper. That's for us. So therefore, I think a good thing to do is to put that down here as a private method. You can write private methods. It just means that only the tree can call it on itself, not anybody else. So otherwise, the code will be no different. So let's write this tree print helper code. If I go back here, if I have a void print helper, it's void binary tree print helper, because this method is part of the tree class, part of the tree object. So I have to put binary tree at the start of it. So I think this is where we write the code that's more like what we were putting here. We say something like, instead of printing root data, root left, root right, I think what we really mean is to say node data, node left, node right. Because it's like whatever part of the tree I'm looking at, print its data, and then go down to its left and go down to its right. That will help the recursive calls be in the right place, right? Usually when we have a helper and a main function that calls the helper, the main function's job is just to get the helper started, right? So from print, I probably need to call print helper and pass what? Pass the root. That's the only thing I have to pass. Start at the top and go down, basically. So print the data, and then print the left, and then print the right. There is an important thing that we haven't thought about. Oh, sorry, these should say print helper, not print. Whenever you write a recursive function, there's an important thing that you have to do, and we haven't done that here. What's missing from our recursive function? We don't have a base case, right? Eventually, you have to stop going down the tree, or else we're going to hit null and probably crash the program or something, right? So I think what we want to do is, like, if we reach a null node, we don't want to go any further. So you could imagine like, well, maybe I'll print the data, but then if the left isn't null, I'll go down the left, and if the right isn't null, I'll go to the right. You could do something like that. But I think an easier test is to say, if this node that I'm at is null, then just don't print anything. Else, print its data, go to the left, and go to the right. And what will happen is if the left is null, the next call will go straight in here and do nothing. If the right is null, the next call will go straight in here and do nothing. You understand? Like, I think that's a cleaner way to write the code. And actually, the way I would really write it would be to say, if the node isn't null, print its data, do the left, do the right. So there's kind of an implicit base case, which is null, do nothing. If null, do nothing. Otherwise, do all this stuff. That's a recursive case. Okay? Well, I don't know if you believe me that it works, but let's try it. We've got print and print helper. I think we're done writing it. Back here in the main, where is the main? We're calling print. Let's see what comes out. Uh-oh. I think here, when I construct tree nodes, I have to say what the data is. I have to say 42. So I have to change this. Let's try again. Wait, and I have like an arrow here. That's supposed to say right, I think? Yeah, okay. Yeah. Wait, multi-line comment. Oh, I've got some stuff down here. Something. Okay, how about that? Okay, let's try again. I'm going to run it. And what does it do? It prints 42, 59, 27, 86. So it did seem to walk around in the tree and print out the different pieces of data that were stored there. We could try making bigger and more complicated trees and seeing if the code still worked, but I think it is working in general. But I wanted to show you this as a first example of how tree methods tend to look. Typically, they immediately call a helper that takes the root, and then the helper does some sort of recursion, and you're stopping your recursion when you hit null-ish. Otherwise, you're going to walk to the left or the right or both, depending on what it is that you're actually up to. That's the kind of template we're going to follow when we add operations to a binary tree. So far, so good. Do you guys have any questions? I mean, we're definitely doing pointers and recursion together, right? I mean, here's the recursion, and here's the pointers. That's what we're up to. So any questions so far? Okay, well, we learned how to print a tree. So again, this is kind of the template. The main function that you're supposed to write immediately calls a helper and passes the root, and then the helper does all the work. Basically, that's what you do, right? We'll vary from this a little bit from time to time, but this is pretty much the template.